Welcome. This is SPSS, PSY 3840, and I'm Professor Fred Coolidge. Let's go to our assignments. We're up to Unit 7. Unit 7 is the t-test for independent groups. While this correlation might be the most popular and most frequently used test statistic, the t-test for independent groups is a statistical analysis for whether two groups' means are significantly different from each other, or whether the difference in the means is simply due to chance. We're going to use this schizoid Asperger's control data set again. But what we're going to learn here as this goal to learn this t-test for independent groups is this statistical analysis. They call it sometimes for a shortcut the independent t. This statistical analysis, if you randomly assign subjects to two groups, there is no more powerful statistical design. Thus, the t-test for independent groups is the most powerful test statistic for analyzing differences between two groups on some variable and determining whether that variable actually causes a difference. And in correlation, just because there's a strong relationship doesn't mean that one causes the other. In this, we can actually hint and imply that if we get significance, the means are different, that one variable, if we followed the design exactly, that is randomly assigned subjects to each group, that the independent variable causes the dependent variable to move. We'll also learn how to test for homogeneity of variance in the independent t-test. And if we get time, we'll go learn about beer making. Let's open up our data set. This is our schizoid Asperger's and controls. On these group IDs, remember we can check the variable if we're not sure. In group ID right here under values, we see that controls are zeros, Asperger's are ones, and twos are schizoid. So we'll say OK. Go back into data view. And let's say our interest is between boys who are 1 and girls who are 2. All boys and girls in this data set. Let's see if their mean autistic symptom survey is different for boys and girls across all three groups. So we'll go up here to Analyze. We'll come down here to Compare Means. And we want the Independent Samples t-test right here. Now notice SPSS has a capital T, and that's just not right. It should be a little t. Now down here is your grouping variable. So what's going to differentiate between the two groups? Well, we said that it's going to be gender. So we'll highlight gender, put it over in the grouping variable, and it says, what are the levels of gender? So we got to define the groups. And we said what we'll do is we'll do boys, which was 1, and 2 for the girls, and we'll do continue. And now what are we going to do for our dependent variable? What's our test variable? We said we'd do the total autistic symptom survey. So we'll kick that over. And we'll go over here and go OK. And this tells us here are group statistics. There's 43 males, there's 28 females. The mean autistic symptom survey for the males is 88. And the females is 70.96. So it looks like there's a big difference in the means. We can see, however, these standard deviations are rather large. And what we're testing is, are the squares of these values, this is the homogeneity of variance assumption, are the squares of these values different? Well, we can also look at the standard deviations. Does it look like they're that much different? No, it doesn't. So the t-test makes the assumption that the variances, the squares of the standard deviations, are equal or approximately equal. So this Levene's test down here, it says Levene's test of the equality of variances, is it's going to assume that the equal variances are assumed, and when it does that, it runs an F test, analysis of variance, and it's not significant. Now what that means is that we can assume equal variances. We haven't violated the assumption of homogeneity of variance. These are enough alike that they're not significantly different. Okay, now let's go to the important t-test. The t-test for independent groups is going to test the mean on these autistic symptom surveys between boys and girls, and it certainly looked like they're far apart and have some practical significance, but it's up to the t-test because these standard deviations, or the variances, the square of these values, are so large. And what we see is, here's our official t-value, so we can go equal variances assumed, so we'll use this t-value. We get a t-value of 2.270, 69 degrees of freedom, that's n1 plus n2 minus 2, so this comes up to 71, and this says 69. And is that t-value significant? Yes, it's less than 0.05. And in fact, it's p equal to 0.026. So that means that this is statistically higher. This mean for the males is statistically significantly higher than for the females. And we're not as concerned with the mean difference. That would be the difference between subtracting this one from this one, or the standard error of the difference, or a 95% confidence interval. If we were interested in confidence intervals, of course, that would be here, but this is our primary focus. Now let's practice that again. So let's go to Analyze, Compare Means, Independent Samples t-test. And this time, let's do this. We'll kick back total autistic symptoms, and let's look at this schizoid personality disorder scale. And we'll use that as our dependent variable. But now, I'm going to kick back the grouping variable. I want to see in the group IDs whether the Asperger's group is different than the loner children or the schizoid children. So we already had the defaults here for 1 and 2, and that was group 1 is going to be Asperger's. Group 2 now, this is not representing gender any longer because we put group ID here. And so we defined groups. It came up 1 and 2, but that was from the previous default. So now it reflects these are Asperger kids and these are these loner kids. We'll hit continue. And we hit OK. Now we've defined the groups. And now we see there were 19 kids in the Asperger's group, 19 kids in the schizoid group. Look at the mean differences. Not much of a visual difference here. And the standard deviations, the squares of these values, the variances look equal or approximately equal. So we would be surprised if we violated the assumption of homogeneity of variance. We come down here. We see equal variances assumed. It's not significant. So that means we can't assume equal variances. We didn't violate the assumption of homogeneity of variance. We see the t-value is even less than 1. n1 plus n2 is 38 minus 2, 36 degrees of freedom. And we can see the significance, not even close to being significant. This has to be less than 0.05. So what we've seen is now we can conclude that the mean level of the schizoid personality disorder for the Asperger's group is similar or approximately similar to the schizoid group. Now we do see a little bit of a mean difference, but this difference now, because of the significance level, means it's totally due to chance. And that's our lesson for today.